Hello and welcome to thank you for joining us on this talk on UPS infrastructure, sustainability and whole of life considerations. My name is Ambrose McNevin and I'm joined today by Keith McLean Martin, who is Technical Manager at Pillar UK. And today we're going to have a discussion which would explore some of the sometimes overlooked aspects of UPS investment, ownership and operation. And we're going to do this, I would say, from a financial and from a sustainability and from a carbon cost perspective. So Keith, welcome. I'm going to hit you with a question, if I may. In the context of sustainable infrastructure, how do you think that risk has been redefined?
Thanks, Ambrose. Yes. So I guess to date, clients think of risk in terms of financial and technical elements, with sadly little or no mention at all in their discussions of sustainability. In the world we live in now, this cannot be the case anymore. Risk must be viewed in measured carbon cost, in new and emerging sustainability metrics, methods and statements, and financial outcomes. But perhaps most importantly, this is about long-term whole of life calculations. It has been the case that even when making long-term infrastructure investments, people are very bad, ultimately, at thinking in terms of decades or longer-term investments strategies. But with this, with the typical working life of this equipment, that's got to be the discussion and the thought process here. We've got worldwide regulatory bodies have guidance to deliver sustainable energy to all businesses, and these include things like the IEEE 1547. For the integration of renewable energy to the grid, and the soon-to-be recast European Energy Directive, which includes a drive to make buildings more energy efficient. So with the world staring over a cliff edge for the environment, you've got to see failure to adopt the correct metrics and methods to meet these emerging emissions and efficiency standards could result in tariffs and in the worst cases, in fact, imposed heavy penalties.
It's so true that in the data center space, especially, we're talking about a 25-year, 30-year capital asset with, as you say, infrastructure. We used to IT equipment getting refreshed every 3 to 5 years. It's like, but we're talking about infrastructure that's going to run for decades. So we need to consider the sustainability implications from every possible aspect. So let's explore that a little further. What are the factors? What factors are in play?
So it's interesting. So sustainability should be assessed in sort of 3 stages, covering the whole life carbon impact, much as you do with financial assessments, do for the whole life cost. So you start with the carbon prior to installation, so that's the manufacturing. You've got the carbon during use, and the carbon after use, which is the recycling and the disposal of the equipment. But perhaps by far the most significant and overlooked stage is the carbon during use. This is less talked about and considered here. We can see, though, on the slide, looking at the different types of technologies, the types of savings that can actually be achieved based on different technologies and how they're imposed and considered here.
Okay, well, let's jump a little bit further into the kind of life cycle analysis and the bits that are not being considered. So what about, are people thinking enough about the carbon cost on things like maintenance, mean time to repair, that type of thing?
It's interesting. So you've got the whole life cost, which during the operational life, you've got 25 years of lifetime here to perhaps consider. So the carbon from maintenance might appear obvious with just general attendances, but what about areas such as component replacements, fault attendances? There's carbon to be factored into all of these components and the additional visits required to keep this equipment operational at all times. So what you've got is every break fix incurs a carbon cost, which includes site visit logistics, and just as importantly is the component manufacture and supply chain and recycling of those individual components. What we've seen, though, is some technologies out there, advances in them, they've moved to actually repair equipment by doing complete power assembly replacements just to rectify the fault. What that then sees is these components, these power assemblies, are then shipped back to the manufacturer for repair and then returned back to site as a service replacement. We've got a question: how is this really sustainable philosophy though? So equipment sustainability needs to be viewed through the lens of how the operational carbon will be impacted by the reliability of the equipment. When you suffer frequent failures requiring more attendances and more component replacements, how can that be sustainable? So shouldn't we look to deliver sustainability through reliable quality equipment? So we can expect now that the sustainability agenda will mean energy intensive industries can expect new energy use and efficiency audits and reporting regimes to become a part of their everyday operations here, which govern their sort of reporting metrics here.
What I'm hearing there and what's really interesting is that from what you've described in terms of the way things are happening today, it doesn't sound very circular. It sounds more kind of throwaway. And when it comes to measuring every aspect of your carbon cost of operation, then, as you say, this has to come down to every element, which you can probably expect from these new regulatory regimes, from policies that are going to become increasingly kind of stringent and demand more data about exactly how your operation is performing.
It's so true, and it's so familiar from the manufacturing perspective to the recycling aspect of the equipment. But it's that section that happens in between those two sort of key definable parts that is currently being overlooked at the moment.
That's interesting. Yeah, people think about efficiency and power use, but not about actually the maintenance and the component use and the kind of whole of life nature of that, as you say, from raw material to recycling, that circularity. Okay, so let's kind of put a bit of context on this. I've heard about the concept of a power triangle.
Yep.
So can you run me through that? What exactly are we talking about here?
Okay, so what we've got here, trying to define how power flows here. So power infrastructure was designed to flow in one direction, generally looking from the grid incomer, following a nice linear path down to the load. Simplistically, this is also how the national grid was designed, coming from the power stations all the way down through the distribution to the point of use. The introduction here of renewable generation and energy storage at different locations throughout the network has changed how power flows through this network and ultimately complicated the model. So you've now got system operators across the world have acknowledged that inverter-based resources, transmission and distribution is only going to become more complex as we evolve the networks to integrate and embed more renewable generation and storage systems. So the original power triangle allowed the energy storage to power the load when there was no grid available, sort of maintaining that nice simple power flow. Now the new power triangle introduces power flows from the energy stored directly to the grid. This is offering huge opportunities for facilities to support the national grid to deliver their sustainable power requirements governed by policies around the world now.
Okay, so why is that relevant then? Why is it relevant to cost, both carbon and financial, and the calculations that people need to make?
Okay, so data centers have got huge, installed huge infrastructure. That includes embedded generation and energy storage capacity. Such power capacity is rarely used more than a small fraction of its design intent to protect the critical load. Ultimately, that's always got to be the key driver of that critical load. But the opportunity here exists to utilize some of this asset without increasing the component's carbon impact. And this can be offset and reduce the site's carbon impact as well.
And now we're talking, just to be absolutely clear, what we're talking here is about why UPS infrastructure is important, because we're hearing a lot about and importance specifically to demand response, to dispatchable power. This idea that the data center the power infrastructure embedded in the data center can have a different role without losing its primary function of protecting the load.
Yeah, that's correct. And we're certainly seeing more and more talk in the industry about it. And even to the point where even data center operators across Europe are saying that sustainability wise, we're not doing what we can do. We've got to do more. And to some extent, this isn't a golden opportunity here to capitalize on schemes that are available from the national grid already, are tried and tested in technologies, and can offer the ability to see financial returns, but also reduce the carbon impact by ultimately supporting the national grid in all aspects of them delivering their sustainability. Because we've got a picture, it's a much wider picture that we've got to talk here in sustainability. We've got to almost look at the whole picture rather than just insularly in our own little world here. So there are different models to achieve this and reducing the energy used by the grid. So you can look at reducing usage of energy at peak times, so peak lopping, or even actually providing real power back to grid is another option that users can offer here. And there are different metrics that allow that usage.
And I guess we hear talk that we know that the grid operators have to introduce more renewables, RERs, more renewable energy resources, and that they inherently, the closer they get to 100% renewable, it's asynchronous, potentially introducing more instability into the grid. So a greater role for infrastructure potentially, such as UPS infrastructure.
Yeah, absolutely. I mean, the grid operators are now playing this constant balancing game between what is the base load generation they have, the usage of intermittent renewable generation, and ultimately to balance that against what is the continual usage. However, they've always got to maintain a certain amount of reserve to cater for these dynamic changes to load that can happen. And as they shift this to towards the 100% sort of renewable, it becomes a much greater challenge to manage that. And that's why they've introduced these metrics of the usage of dispatchable power through the demand side response to allow them much greater flexibility to manage their grid. And this is where now you've got what used to be the district network operators. They're now managing and operating these systems, and in fact they're now being termed district system operators, because they've got this much greater responsibility to play to manage the power flow in different directions from different assets and from the point of use to generation here.
That's really interesting. So I mean, we're kind of talking about a little bit of data centers. Do you think there might be should we say a kind of an unwillingness or a lack of engagement because they don't trust the infrastructure that they have to be able to perform this? And we're talking at a UPS level.
I think that there's a nervousness, absolutely, and I think we've got to sort of start to engage and trust in the equipment that it's there to do the job, and ultimately any UPS is always, its primary function, let's face it, has got to be to protect the load and the critical load, and all the safety systems, all the control systems are always going to be favored and biased to ensure that is there to do so. And with regular maintenance, regular testing, regular reassurances, essentially that the clients can gain from this, from testing, from usage of the equipment, the confidence to deliver these systems should be there. I mean, we've got systems that have been doing this sort of demand side response now for clients for 4, 5, 6 years probably now, and it performs reliably, and there are great benefits financially, obviously, but also in the offset of carbon that they're now enabling grids to sort of benefit from as well.
So I guess the final point there is that if they have the right infrastructure, there's an opportunity and an opportunity cost of not doing it, which is engaging with the national grid to help them deliver the most sustainable power possible.
Yeah, that's correct. And you never know. And in the worst case scenario, you might see ultimately legislation or requirements kind of almost imposing this and forcing this onto customers and clients without their prior planning or thought process. So when you've got all this infrastructure out there, let's face it, it could be called to operation and almost drafted in to be used at some point in the future, perhaps.
I know there are conversations going on in certain territories where that which with dense, should we say, very very kind of dense clusters of data centers. I know there are grid operators who are already pointing to them and talking in exactly these terms. Okay, so let's talk about then. Kind of jump into energy storage. Energy storage is key. We hear about this on a grid level, so it's obviously going to be key at a data center level as well. So the question then becomes, in this context, can it be sustainable?
Yes, gosh, I mean, energy storage certainly plays a key role to deliver sustainable goals, and that's at all levels of infrastructure, from the highest level of grid down to ultimately the point of use here. The development of different battery chemistries ultimately is going to be the key driver to deliver the best sustainable products into this space here. But we must remember that without an inverter, the electronics associated with that, the energy stores can't actually deliver that power back to grid. So these have got to be factored into the reliability, the carbon usage, albeit they are now being shared perhaps with the UPSs. So you've got a shared sustainability here. But what we don't know is perhaps, is that going to cause more failures? Is that going to impact that side of the sustainability? So again, making the importance of the operational efficiencies of sustainability and carbon important in this talk as well here. So, but what we might see is in the long term, we might get new technologies that emerge. There are already things such as solid state batteries, whether it's green hydrogen power fuel cells, where you've got perhaps hydrogen being produced from spare renewable energy capacity, or perhaps, let's all keep fingers crossed, let's say, for nuclear fusion. There could be, though, a time when existing technologies are ultimately become redundant, but we cannot simply wait for these technologies to be developed and deployed ultimately at scale. So that means what we must do is make the best sustainable power infrastructure decisions today, as this is going to be key to delivering near and long-term sustainability now and over the coming decades from the infrastructure that we have in place that's going to be supporting this these facilities here.
And I think that's really important, because I think in the data center, even in the data center sector, energy intensive, lots of very smart power engineers, lots of very smart electrical engineers. Sometimes we forget that we can't wait. You know, we all want to run hydrogen that's been electrolyzed using spare renewable energy resource capacity, but this stuff isn't coming for years. And in the meantime, we have to make the steps to sustainability where we can, and start to slice away and chip away at the carbon cost of operations in any way possible. We simply can't wait, as you say yourself, for this to come in and scale. Otherwise we would not be doing anything for a decade, and that's simply not feasible. Yeah, so that brings me to kind of a question around the way things are changing and the role of the UPS as within it. So, there are new energy sources and there are new applications, new grid applications such as microgrids. Okay, so what's the role of the UPS there?
Yeah, it's interesting. I mean, I think we've seen as facilities have grown, I think we can see more and more frequently now the power infrastructure almost moving outside of the data center. The two shouldn't be sat next to each other or in the same space, because ultimately they perform two different functions. So the development of microgrids here allows the integration of multiple renewable generation sources, and ultimately can decarbonize the energy used by that data center, by the IT equipment here. The UPS here will play a vital role in managing the power quality and the balance between these generation sources to support the load without any sort of fluctuations, and maintaining that high quality required by all those servers. Now, microgrids here this has got to be considered both in Ireland or ultimately integrated directly into the grids. They're all developing really rapidly here. Lots of different systems out there. But the UPS here can also play a unique role here to isolate the site from the grid. This offers the benefit of reducing the risk of disturbances from the national grid affecting site operations, kind of creating yourself islanded, but still having that support there of the grid in those concerning in those times of sort of at-risk operations, perhaps. So it offers that further stability, but de-risks the operations here.
That's what's really interesting. Again, the big context for this is the energy transition, which you've touched upon a couple of times. I think is that we know that energy transition at a global scale has to decarbonize, and different nations, different countries, different grids and generators have their own roadmap toward that. But it's not that long. It's 5, 10, 15 years, which inherently makes the grid more generation and it makes it more complex for generators, transmission systems operators, distribution systems operators. And as you say, as they bring more inverters on, they bring more renewable energy resources on, the closer you get to net zero, the more unstable potentially the grid becomes, which means all options have to be on the table for how energy intensive, infrastructure heavy, capacity heavy operators such as data centers engage with these with the energy sector and the different players within there. And as you say, the vital role for the UPS infrastructure, which is on-prem, which is embedded.
Yeah, absolutely. Gosh.
So we're talking big. This is big stuff. We're talking for potentially for operators, which again goes back to the time to start thinking about it is now. I think because this is not something that's going to go away. So it's going to become more important. So how important our whole of life ROI calculations to cost analysis in this changing power landscape. It's one complex. I mean, it can be seen as it's a complex picture, but it's specifically in whole of life ROI calculations.
Yeah, it's interesting. I mean, as you say, that power landscape is changing really rapidly, and we've seen really impressive movements in the last between 2013 and 2020. There was a 65% decrease in emissions from the grid. That's a huge improvement. But the national grid has now got even more significant targets over the next 10 years to achieve the targets that have been announced in government policies. And that's going to see the grid power generation decarbonized to a point where supporting 100% of the grid can be achieved with zero fossil fuel generation by the year 2035. This is a huge step change in just over 10 years now. So as governments move the world to introduce these new policies and set new targets, how we use this energy will be subject to tighter and tighter regulations here. Investment in the right infrastructure now will allow the support of these national goals and help big power users more easily integrate with the utility partners while benefiting from the incentives and ultimately, hopefully, avoiding potential sort of carbon penalties that might be seen in the future for those really inefficient, wasteful users of energy. So this is the basis for the true end-to-end and whole-of-life financial and sustainable UPS ROIs.
That's exactly right. Again, you've touched upon it. Again, we can't predict. Well, we can forecast probably quite accurately what the policy regime, the environmental regulation environment is going to look like. What those policies are coming down the track at us. And we've been nothing if not ambitious today. We've addressed some pretty big topics, but we haven't had a great deal of time. So what can people do to find out more?
Yeah, certainly. I mean, gosh, it's this talk is really quite a short one, but we've tried to set out sort of quite a really high level sort of perspective on just some of the issues and opportunities in a very complex and rapidly evolving topic. Ultimately, for more on how your choice of UPS infrastructure will impact your organization's sustainability strategy, pillar.com has got many resources available. And for those of you who wish to find out more and continue the conversation, please connect with us and follow us on LinkedIn and follow on Twitter, using the details that we've got here on the screen. Pillar experts are available to discuss in-depth all technical, financial and sustainable aspects of your UPS infrastructure investment and operation. So we look forward to seeing you more and extending this conversation. And thank you really very much for your time today, and look forward to engaging again in the future.
Thank you, Keith.
Thanks, Ambrose.